What if I told you that a single photograph from this new telescope would require 378 4K TVs to display at full resolution? The Vera Rubin Observatory has just released its first images, and they're unlike anything we've ever seen before. This isn't just any telescope. This monster uses the largest digital camera ever built, a 3.2 gigapixel eye so massive it's literally the size of a small car, weighing nearly 2,800 kilograms. To put that in perspective, one single image from this thing would need 300 feet AV 4K TVs stitched together just to display it in full resolution. But here's where it gets wild. This camera isn't looking at one galaxy or one planet. It's scanning the entire sky, again and again, in a way no observatory has ever done before. Every night, it captures the whole universe in motion. Stars exploding, asteroids shifting, galaxies colliding. Every cosmic event we've missed until now. And the question that's keeping scientists awake? What happens when we can finally see the universe changing in real time? Because once this data starts rolling in, it could expose things we've never witnessed. New planets, hidden asteroids, maybe even signals of something far stranger. Now, here's where things get insanely futuristic. You've seen how massive the Rubin Observatory's camera is, but the images it captures? They're so enormous and so detailed that handling them becomes a scientific challenge of its own. Every single night, this observatory gathers nearly 20 terabytes of raw data. That's the equivalent of downloading the entire Netflix library. Not once, but multiple times, every single day. Think about it. 20 terabytes per night, every night, for 10 straight years. By the end of its mission, the Vera C. Rubin Observatory will have accumulated around 500 petabytes of cosmic data. That's 500,000 terabytes. More data than any observatory in human history has ever produced. It's like photographing the entire universe in Ultra HD, over and over, from every angle, and then stacking it all together to reveal patterns and events we've never even imagined. But here's the mind-blowing part. This data doesn't stay in Chile. It travels through a dedicated 100 gigabit per second fiber optic line that stretches thousands of kilometers from the observatory in the Andes all the way to data centers in Miami, Florida. Picture it, light-speed streams of cosmic information pulsing beneath the ocean, raw snapshots of exploding stars, shifting asteroids, and colliding galaxies, racing from one side of the planet to the other in real time. And this connection isn't just about speed. It's precision engineered for reliability, because if even one tiny packet of data goes missing, scientists could lose an entire cosmic event. Maybe the exact moment a star dies or a new world forms. Every bit of information matters, and the system has been built to protect it like treasure. Before we dive in, hit that subscribe button and turn on notifications. You don't want to miss any updates on the universe's deepest secrets. And if you love exploring hidden mysteries and unexplained discoveries, give this video a like so we know to keep uncovering them. Now imagine what happens when this river of data hits the world's supercomputers. Thousands of processors instantly begin comparing images, frame by frame, night after night, looking for anything that's changed. If a dot of light appears where there wasn't one before, boom, that could be a new asteroid heading our way. If a faint galaxy suddenly brightens, that might be the birth of a supernova. It's like the universe is sending us a constant live update, and for the first time in history, humanity has the tools to actually keep up. Every pixel, every fluctuation, every cosmic whisper is being captured, analyzed, and shared faster than ever before. But here's where curiosity skyrockets. What if, hidden in all that data, there's something no one expects? Something that doesn't behave like anything we've ever seen? Scientists are already preparing for surprises, not just discoveries, but mysteries. Because when you start recording the universe in this much detail, you're bound to find things that don't fit. And in just the first weeks of operation, the Rubin Observatory's data pipeline already caught something unusual, a flicker of light from a distant part of the sky that no one can explain. So, The question is, what exactly did the world's most powerful telescope just find hiding in plain sight? Before we dive into the mysteries the observatory is about to uncover, you need to know the story behind its name, because it's not just a telescope. It's a tribute to one of the most groundbreaking scientists in history, Dr. Vera Rubin. Back in the 1960s, when computers filled entire rooms and women in astronomy were almost unheard of, Vera Rubin stood out, not because she wanted fame, but because she saw something no one else did. She was studying how galaxies rotate, measuring how stars moved around their centers, and what she discovered shattered everything we thought we knew about the universe. As Rubin studied spiral galaxies, she noticed something impossible. According to Newton's laws, stars at the edges of galaxies should move slower than those near the center, just like planets in our solar system. But that's not what she found. The stars on the outskirts were moving just as fast as the ones near the core. It made no sense, unless there was something invisible holding those galaxies together. That something would go on to become one of the greatest mysteries in all of physics: dark matter. An unseen substance that makes up about 85% of all matter in the universe, yet we can't touch it, see it, or detect it directly. Vera Rubin didn't just find a new clue. She exposed a hidden framework of the cosmos itself. But here's what makes her legacy even more powerful. She made these discoveries while facing barriers that would have stopped most people. At a time when many universities wouldn't even let women use observatories, Vera was raising 4 children and changing the course of astronomy. When asked how she managed both, she simply said, "There is no problem in science that can compare to the courage needed to raise a family." And now, decades later, her name watches over the heavens. The Vera C. Rubin Observatory isn't just honoring her. It's continuing her mission to uncover the unseen. Every pixel this telescope captures, every new phenomenon it records, brings us closer to understanding the dark matter she first revealed. It's almost poetic, a telescope designed to map the hidden universe named after the woman who first proved that most of it is invisible. Her discovery turned astronomy on its head, and now her namesake might finally reveal what dark matter really is. But the real twist? Some scientists believe the Rubin Observatory might detect something that goes beyond dark matter, something even Vera Rubin herself could never have imagined. So what if the very thing she discovered, the invisible glue of the cosmos, isn't just matter at all, but a clue to an even deeper layer of reality? Now, let's talk about where this technological beast actually lives, because it's not sitting in some random observatory. The Vera C. Rubin Observatory is perched high above the world, on Cerro Pachon, a remote mountain peak in Chile's Atacama Desert, one of the driest, clearest places on Earth. Imagine standing there at night. No humidity, no city lights, just the Milky Way stretching from one horizon to the other. This desert is so dry and so high up that the air barely holds any moisture, meaning starlight reaches the telescope with almost zero distortion. It's as close as humanity can get to viewing space, as if we were floating above the atmosphere itself. That's why almost every major observatory, from the Gemini South to the upcoming extremely large telescope, calls this desert home. But even among giants, the Vera C. Rubin Observatory stands apart. At its core lies the Simone Survey Telescope, the 7th largest optical telescope on Earth. Its main mirror, a staggering 8.4 meters across, captures more light in one night than smaller telescopes could gather in weeks. But here's where things get crazy. It's not just one mirror. This telescope uses a 3-mirror system, something almost no other observatory on the planet has. Here's how it works. The massive 8.4-meter primary mirror collects the light. Then, that light bounces up to a 3.5-meter secondary mirror and finally hits a 5-meter tertiary mirror, a design so unique it corrects distortions that most telescopes simply can't avoid. The result? Razor-sharp, ultra-wide images that cover a section of the sky 7 times larger than the full moon in a single shot. This triple mirror design doesn't just make it powerful, it makes it revolutionary. It allows the Rubin Observatory to map the entire visible sky every few nights, something no telescope has ever been able to do before. Instead of staring at one distant galaxy for months, it captures everything, everywhere, all at once. Supernovae, asteroid trajectories, galaxies twisting in slow motion. It's all recorded in unbelievable detail. But here's where your mind might really explode. The precision of this design is so extreme that if one mirror were off by even the width of a human hair, the entire image could blur. To prevent that, the mirrors are actively controlled by a system of sensors and motors that make microscopic adjustments hundreds of times a second. It's like the telescope is alive, constantly refocusing itself on the universe with machine-level precision. And when that perfect focus combines with Chile's pitch-black skies and the most powerful camera on Earth, the result is unlike anything humanity has ever built. An eye that can scan the heavens faster, deeper, and more accurately than any before it. But here's the real question. What happens when a telescope this advanced, with the clearest view on the planet, spots something that shouldn't be there? Because some of the first test images from Cerro Pachon already revealed an anomaly that scientists still can't explain. Now we've arrived at the heart of this cosmic machine. The LSST camera, the crown jewel of the Vera Rubin Observatory. This isn't just a camera. It's the most powerful digital eye ever created by humankind. Every part of it was designed to carry out one of the most ambitious scientific projects in history. The Legacy Survey of Space and Time, or LSST for short. Over the next 10 years, this camera will photograph the entire visible sky again and again, creating a time-lapse of the universe itself, billions of galaxies, countless stars, and everything that moves, flashes, or explodes in between. But to do that, the camera had to be built on a scale that sounds almost unreal. It's 3 meters long and 1.6 meters wide, about the size of a compact car, and weighs a staggering 3 tons. The engineering that went into it is nothing short of sci-fi. Inside, it holds 189 custom-built CCD sensors, each one capable of capturing tiny, razor-sharp detail. Together, they create a 3.2 gigapixel image, so detailed that if you printed one photo at full resolution, it would be the size of a basketball court. To put that into perspective, one single image from this camera covers 10 square degrees of the sky. That's the equivalent of photographing 45 full moons at once. Imagine that, one snapshot capturing tens of millions of stars, galaxies, and cosmic objects in stunning crystal clarity, and then doing it again and again every few nights for an entire decade. But here's where it gets even more incredible. The LSST camera isn't just taking pretty pictures. It's equipped with interchangeable filters that can see in ultraviolet, visible, and near-infrared light. That means it's not only showing us what space looks like, it's revealing what it's made of. Scientists can study the age, temperature, and chemical makeup of objects billions of light years away, simply by analyzing the light this camera captures. The precision is insane. Each exposure lasts only 15 seconds, but in that blink of time, the camera can detect stars dimmer than anything the human eye could ever see, up to 24th magnitude, billions of times fainter than what's visible from Earth's surface. And every night, this massive camera will collect millions of images, feeding them into the Rubin Observatory's data pipeline, scanning, comparing, and identifying every single change in the sky. A new asteroid? Detected? A dying star? Captured. A mysterious flash from the far edge of the universe? Logged and analyzed instantly. It's like having a security camera for the entire cosmos, one that never blinks, never sleeps, and records everything that moves. But here's the question that keeps astronomers, and honestly, a lot of us, wide awake. What if this ultra-sensitive eye captures something no one can explain? Because when you give humanity the power to watch the universe in real time, you're not just observing, you're inviting the unknown. And the LSST camera is about to show us things that will make even seasoned scientists question what's really out there. Here's where the scale of the Vera Rubin Observatory goes from incredible to absolutely mind-melting. Most telescopes spend weeks, sometimes months, staring at one tiny patch of space. But this one? It's doing something no human instrument has ever done before. Every 3 nights, the Rubin Observatory will map the entire southern sky, that's half the visible universe, in one continuous sweep. Imagine photographing 50% of the sky, from horizon to horizon, every 72 hours, and then doing that again and again for 10 straight years. What you get isn't just a set of pictures. It's a living, breathing time-lapse of the universe itself. Every star that flickers, every galaxy that shifts, every asteroid that changes course, every explosion, collision, or burst of light that's ever happened, captured, cataloged, and compared in real time. We'll literally be watching the universe move. To understand just how insane that is, let's compare it to what came before. The Sloan Digital Sky Survey, one of the greatest astronomical projects ever built, took 20 years to map only 35% of the sky. And even then, it couldn't update its images fast enough to catch rapid changes. The Vera Rubin Observatory, it'll do the same job, and more, in just 3 days. Let that sink in. What once took 2 decades of data collection can now be achieved 8 times faster in a single week. Rubin isn't just another telescope. It's a time machine, watching the cosmos evolve moment by moment. Each full sky scan adds to a massive, ever-growing archive, billions of images stitched together to create a detailed 3D movie of the universe, spanning billions of light years and millions of years of cosmic evolution. For the first time, scientists can literally see how galaxies twist, how stars die, how the universe expands, not as theory, but as a visible sequence of events. But here's where it gets wild. Because the observatory is mapping everything in such rapid succession, it's also going to capture the unexpected, the things that don't repeat. Fast-moving asteroids that could pose a threat to Earth, unexplained flashes of light that last for seconds, even entire galaxies that appear to warp or dim for reasons we can't yet explain. Think about it. The universe is in constant motion, but until now, we've only ever seen still frames, snapshots in time. The Rubin Observatory is flipping that script. It's giving us the movie version, and that means we might witness things that challenge our understanding of physics itself. So when the first few months of data start rolling in, astronomers will be watching closely, not just for what they expect to see, but for what they don't. Because when you can scan half the universe every 3 nights, you're bound to find something that's never been seen before. And rumor has it, in its very first test scans, it already did. Now that you know the scale, the speed, and the sheer power of this machine, here's the why. Why build something this massive, this complex, this ambitious? Because the Vera Rubin Observatory wasn't designed just to look at space. It was designed to change what we know about it. This observatory has 4 core missions, and each one has the potential to rewrite science books for an entire generation. First, it's going after one of the biggest mysteries in the universe, dark matter and dark energy. Remember Vera Rubin's discovery? The invisible force holding galaxies together? Well, this telescope is finally equipped to hunt for the evidence she could never see. By tracking how billions of galaxies move and how their light bends through space, scientists will measure the invisible gravitational fingerprints of dark matter. And beyond that, they'll study dark energy, the strange, unseen power that's literally pushing the universe apart faster and faster. Every image, every shift, every flicker helps scientists map how the cosmos is stretching, giving us our clearest view yet of the universe's hidden architecture. And if the results don't match predictions, it could mean our understanding of physics itself is wrong. Second, it's about our own solar system, but not the part we already know. The Rubin Observatory will be tracking asteroids, comets, and even interstellar visitors like Oumuamua and 3I Atlas that enter our system from deep space. With its rapid sky scans, it can detect moving objects that other telescopes completely miss, even those that could one day pose a threat to Earth. Imagine this: a rock the size of a city, drifting unnoticed through the dark until the LSST spots its motion between two images taken just hours apart. That's how powerful this observatory is. It's literally Earth's early warning system for the universe. Third, it's monitoring transient cosmic events, the short-lived, high-energy outbursts that define the drama of the cosmos. Supernovae, gamma-ray bursts, variable stars, and mysterious flashes that appear for seconds and vanish forever. With Rubin's speed and precision, astronomers can catch these moments as they happen, not days later. It's like having a front-row seat to the universe's most explosive events. And finally, the fourth mission, to map the Milky Way itself like never before. Billions of stars will be charted in 3D, revealing how our galaxy spins, evolves, and connects to its neighboring systems. Scientists will be able to trace the flow of stars across space, uncover hidden stellar streams, and maybe even find new clues about where our own solar system came from. Together, these four missions make the Rubin Observatory not just a telescope, but a cosmic detective. It's searching for dark matter, scanning for danger, watching the universe explode in real time, and mapping the galaxy we call home. But here's the question that no one can answer yet. With all this power, all this data, and all this speed, what if it finds something that fits none of these categories? Something we didn't even know we were looking for? Because when you build a machine to see everything, you also open the door to the impossible. And if history has taught us anything, it's that the universe always has surprises waiting just beyond the edge of what we can see. Now the moment we've all been waiting for. The first images from the Vera Rubin Observatory are finally here, and they are nothing short of jaw-dropping. Scientists are calling them a cosmic treasure chest, and it's easy to see why. The first mosaic targets the Virgo Cluster, a massive grouping of galaxies about 55 million light-years away. To create this image, the telescope stitched together 1,185 individual exposures, and what it captured is staggering. In a single frame, you can see 10 million galaxies, each one a universe of its own. And that's just the beginning. Over the course of the full survey, Rubin is expected to capture 20 billion galaxies. That means this first image is only 0.05% of the full dataset. Every pixel holds secrets, and we've only scratched the surface. But it doesn't stop there. The Rubin Observatory also turned its gaze closer to home, producing a breathtaking Lagoon Nebula mosaic. Using 678 exposures, it reveals not just the Lagoon Nebula, M8, but the Trifid Nebula, M20, Messier 21, and the Globular Cluster, NGC 6544. The detail is phenomenal, and it highlights one of Rubin's biggest advantages over space telescopes like Hubble, its enormous field of view. While Hubble zooms in on tiny sections of the sky, Rubin captures huge swaths in a single shot, giving scientists a massive, contextual view of the cosmos like never before. Every one of these images is a data goldmine. Astronomers are already combing through the mosaics, identifying new galaxies, faint stellar streams, and rare cosmic events that might have gone unnoticed for decades. And here's the kicker. These first releases are just a preview. They're snapshots from testing and early observations, not even the full survey yet. If this is what we see in the opening weeks, imagine what the Rubin Observatory will reveal over the next 10 years. Billions of galaxies, asteroids, transient events, and perhaps phenomena that defy everything we think we know about the universe. In other words, these first images aren't just beautiful, they're revolutionary. They're a promise that the universe we thought we understood is only the tip of the iceberg. And every night, Rubin is gathering more pieces of this cosmic puzzle, one breathtaking mosaic at a time. The big question now, what hidden wonders are waiting in the remaining 99.95% of the survey? Something tells us we're about to find out. Even in its first 10 hours of operation, The Vera Rubin Observatory proved that it isn't just a telescope, it's a cosmic game-changer. Imagine a machine so powerful that in less than half a day, it could scan millions of stars, galaxies, and objects, and already start uncovering things humanity had never seen before. That's exactly what happened. One of the first major achievements was the discovery of 2104 new asteroids. That's right, in just 10 hours, Rubin spotted over 2,000 previously unknown rocky bodies drifting through our solar system. Among these, 7 were near-Earth objects, though none posed any threat. But the fact that the telescope can detect such tiny, fast-moving objects so quickly is nothing short of astounding. With each passing night, Rubin's observations will expand asteroid catalogs exponentially, giving scientists an unprecedented understanding of the neighborhood around our planet and helping safeguard Earth from potential hazards. But Rubin didn't stop at asteroids. It also found 46 RR Lyrae stars, pulsating stars that act as cosmic mile markers, helping astronomers measure distances across our galaxy. These stars are like lighthouses in space, allowing scientists to map the Milky Way's structure with unparalleled precision. And the best part? This is just the start. Over the full 10-year survey, Rubin could identify hundreds of thousands of RR Lyrae stars, revealing hidden stellar streams, dwarf galaxies, and the Milky Way's mysterious outer halo in a level of detail never before possible. Now, think about the bigger picture. The Rubin Observatory isn't just cataloging objects. It's creating a dynamic, ever-changing map of the universe. Every night, it detects movement, brightness changes, and new phenomena. Fast-moving asteroids, fading supernovae, variable stars, even interstellar visitors like 3I Atlas, nothing escapes its gaze. This is the power of a telescope designed to observe the sky as a living, breathing system, rather than static snapshots. And here's where things get truly exciting. These early discoveries hint at what's to come. If Rubin can find thousands of asteroids and dozens of variable stars in just 10 hours, imagine what it will reveal over 10 years of continuous observation. Entire new populations of stars, never-before-seen cosmic explosions, mysterious flashes, and even unexpected phenomena that could challenge our understanding of physics and astronomy. The first 10 hours were just a glimpse, a small teaser of the universe's secrets waiting to be unlocked. Scientists are already combing through the data, analyzing patterns and preparing for discoveries that could rewrite textbooks. And with each passing night, the observatory will build a living movie of the cosmos, capturing motion, change, and cosmic drama on an unprecedented scale. So here's the mind-blowing part. The Rubin Observatory has opened a new chapter in astronomy, one where we no longer just observe the universe. We track it, study it, and witness its evolution in real time. And if these first 10 hours are any indication, what we'll discover in the next decade might completely change how we see our place in the cosmos. The universe is alive. It's moving. It's changing. And for the first time in human history, we have an eye that never blinks, ready to reveal everything it has been hiding. Now let's step back and look at what the Vera Rubin Observatory really means for the future of astronomy. Because this isn't just a telescope, it's a cosmic revolution. Over the next decade, Rubin is expected to discover millions of asteroids, including many near-Earth objects, giving humanity a level of planetary defense and awareness that's never existed before. But that's just the start. It will also spot rare, fleeting cosmic events in real time, supernovae, gamma-ray bursts, and other explosive phenomena that appear and vanish in hours or days. These events have long eluded astronomers, but Rubin is built to catch them all as they happen. Now imagine the sheer scale of its vision. One single image from Rubin covers 4,000 times more sky area than Hubble. While Hubble zooms in on tiny sections, Rubin scans the sky like a cosmic wide-angle lens, capturing massive regions of space in incredible detail. That makes it perfect for mapping the universe on a scale that's never been done before. Galaxies, star clusters, nebulae, asteroids. everything gets caught in a single frame, allowing astronomers to track motion and changes across enormous swaths of the sky in ways previously impossible. And then there's the data. Over its 10-year survey, Rubin will amass around 500 petabytes of information. That's 500,000 terabytes, more data than the entire internet of the early 2000s, all containing precise, high-resolution observations of billions of stars, galaxies, and moving objects. Scientists around the world will comb through this data for decades, uncovering hidden patterns, detecting new phenomena, and solving mysteries that have puzzled humanity for generations. What makes Rubin truly unique is how it combines wide-field imaging with long-term monitoring. It doesn't just take one-off pictures. It builds a living, breathing map of the universe. Night after night, week after week, year after year, it captures motion, change, and rare events as they happen. Galaxies collide, stars explode, asteroids streak across the sky, all recorded, cataloged, and analyzed. The universe is dynamic, and Rubin allows us to finally observe it as a dynamic system, not just frozen snapshots in time. This is more than just science. It's a legacy for future generations. Astronomers, engineers, and curious minds for decades to come will use Rubin's data to explore the cosmos in ways we can't even imagine. Every asteroid tracked, every variable star mapped, every transient event recorded will reshape our understanding of space, matter, and time. And here's the biggest question. If in just its first 10 hours Rubin already discovered thousands of new objects, what will it reveal as it continues scanning the entire southern sky for 10 years? What phenomena have been hiding in plain sight, waiting for the universe's clearest eye to find them? The Vera Rubin Observatory is capturing the story of the universe as it unfolds, giving humanity a front-row seat to cosmic events and leaving a treasure trove of knowledge that will redefine astronomy for centuries. One thing is certain, the universe will never look the same again. If you found this journey through hidden science, cosmic secrets, and potential alien infrastructure as mind-blowing as we did, make sure to subscribe and hit the notification bell. Don't miss future explorations into the universe's deepest mysteries, because some secrets are just waiting to be uncovered.